Okay, it's 1 o'clock. Welcome everyone to our next HDF clinic. I apologize in advance for there might be some glitches along the way because after almost 2 years I'm back in the office just to try it and see how it goes. But my setup here is very different from my setup at home, and so I just might push the wrong button or do something wrong and foolish, and this might be the end of this meeting today, but I'll try. Okay, yeah, I have not acted on this, but I'll get there. Last week's highlights, oh, maybe before I start talking about highlights, I'm breaking from tradition already. Are there any questions? That's the most important. That's why we have this clinic. Yes.
Hi, Gerd. Yeah, I do have a question.
Sure.
It goes back a little bit to our previous discussion on the user block, but the use case is this. Suppose I have something. I'm getting a little bit of echo here, but I'm hoping it comes through on your side. Suppose I have something that I would consider a manifest file that I want to accompany an HDF5 data store, something that should always go with it. What would go in the manifest might be things like which external links to interpolate on initial read of a file, maybe the filters required, maybe even things like which data sets to pre-open for viewing, something like that. But these are all parameters that should accompany, that I don't want to get stranded or orphaned from the original file. Now, so the requirements might be, I'd like to store all of this in HDF5 because there's a lot of benefits to being able to do that. And the second one is I would just never want to decouple it from HDF5. So my question is, can I create a in-memory HDF5 file for the manifest and then write that manifest file, write that image into the user block so that wherever the HDF5 file goes, so does the manifest?
Okay. Yes. So I tried to capture this, and let me just rephrase this. So I think I understood what you would like to put into that manifest file, so to speak. And is it okay for this manifest file to be a text file, like a configuration file where you list sort of keyword equals value? Or because I think you said it should be an HDF5 file, or maybe I misunderstood that.
It potentially, if worse came to worse, it could be a text file with some prearranged format. But the advantage of putting it in HDF5 is that if we're already reading HDF5 for the purpose of displaying it, then there's some immediate benefits because I can almost for free display the manifest and see what the settings are. And also when it's in HDF5, I might be able to gain some real benefit from being able to reference the real HDF5 file from within the manifest. But also the other thing is I don't want to pollute the data namespace in the main HDF5 file. People might be using that HDF5 file for any number of reasons that don't require anything that I would put in the manifest, and they just want to see the data. But for another set of users, that manifest, if they're using the UI, for instance, that manifest might be absolutely necessary. So yes, to answer your question, it could go into a text file, but it would be great if it could just use HDF5 itself to represent all of the info.
Yes, so I think so technically, definitely it can be. We have to do a little trick though. If you remember, the user block is sort of a region in the file that we set aside at the beginning of the file, starting at offset 0, going having to be at least 512 bytes, but then any power of 2 after that is sort of a valid size for a user. And if this manifest file were an HDF5 file, that would be problematic to put that into the user block, at least putting it right at the beginning at offset 0, because then the HDF5 library would actually see the HDF5 signature of that HDF5 file, and it would think that's the only HDF5 file and actually not see the big HDF5 file that's sort of coming later.
Okay.
So that would be a technical problem, but an obvious and easy solution would be to just offset that signature by 1 byte, at least. 1 byte, I mean, some specified amount that you can choose just to signal to the HDF5 library, there is no signature here, and it could be later in the user block, but the library is not going to look there. So you will definitely get away with putting an HDF5 file into the user block of another HDF5 file. So technically, that's definitely possible. And then, yes, in that HDF5 file, the only question then would be, it would be you are creating what I would almost call like a secret handshake. So you know, let's say for argument's sake, the offset of that manifest HDF5 file is 2 bytes. You know that at offset 2 bytes, or when you extract that user block, you know that you have to chip off 2 bytes at the beginning, and then you can read it as an HDF5 file because that's where the signature is. So yeah, I think the only downside would be that you would have to adopt this kind of convention to get around this this limitation that, yeah, if you want that manifest file to be HDF5, that it's got to be offset slightly from the beginning of the HDF5 file to not shadow or to not make that real HDF5 file, of which it is a manifest, to disappear. But then, yes, aside from that, inside of that manifest HDF5 file, you can certainly have external links and things like that, because in the sense of a name in the file system, of course, the real, in double quotes, HDF5 file would show up as a file, whereas that manifest file would be anonymous. It would not be visible as an HDF5 file. So yes, that would be possible. Again, the only caveat is that, yeah, you have to slightly nudge it away from the beginning so that the signature doesn't show up there. But other than that, yeah, it's certainly possible. It can be HDF5. Again, with text, there wouldn't be a problem unless the first bytes in your text file happen to be exactly the same as the HDF5 signature. Right. That would be a problem. But yeah, that should work.
Once the in-core HDF5 file is created, is that image put direct? Would that image be put directly into the user block?
No. You have to do something. There is a actually, I believe it's a file creation property. When you have when you create the sort of the non-manifest, the proper the real HDF5 file, you have to set the size of that user block. I believe that you cannot do that after the fact. What you could do after the fact is you have basically two choices. You can first create that the real HDF5 file and without a user block and just work with it, and then at some point create, for example, that manifest file in core, and then after you closed that real HDF5 file, you could use a command line tool like H5 jam and basically jam that manifest into the real HDF5 file. If you want to do it programmatically, so this would be using a tool. If you want to do that programmatically, you would either have to reopen. Either that my manifest is never going to be bigger than such. So if you know that your manifest is never going to exceed a certain size, so you know it's going to be typically no more than 64 kilobytes. Well, if you always allocate 128 kilobytes as user block size, then you should be fine. And then you could create, when you create the real HDF5 file, so to speak, you could just set aside that user block size of 128 kilobytes, let's say. And then when you have that manifest file in core, you would probably, I mean, just in the interest of safety, I think you would first close the real HDF5 file, so to speak, and then you would just use standard POSIX IO calls. You wouldn't use the HDF5 library to write the manifest file into that portion of the file that you set aside for that user block, because you wouldn't use the HDF5 library for that.
Okay, so it goes directly in as a sequence of bytes, and it's stored that image.
Yes. Yes.
And then so that sounds promising. Okay, all right, that answered my questions, because I really wanted to know. It sounded like it was possible, and there's advantages to doing it, but were there any by the ways that this is not going to work? Any showstoppers? Is what I was.
Yeah. Again, the only showstopper I can see is that if you don't offset the super block of that manifest file from the beginning, then there is trouble, because the HDF5 library will think that the manifest file is the real file, which it is not.
Yes, which is always a possibility, but in this particular case, it's a reality because it's an HDF5 file.
Yeah. And then again, you could, if you really wanted to do this, you could do that fancy, because the user block is a region of the real HDF5 file that is in a way subject to standard Unix IO or whatever the operating system IO layer does. And you could even memory map that region, just that region of the file into memory. And then you could manipulate that memory with just, just like a byte array in memory. Right. And then once you unmap that region, that should automatically push that information back into the HDF. Although it can be tricky then, because I'm trying to think what happens, how do you sell that pointer to that shared memory region to the HDF5 library as the buffer that you want to use for that core file? So I think it's technically possible, one can do it, but step by step, maybe I wouldn't go this far in the first round, because there might be some issues there. Okay, thank you. Great, thank you. Thanks, great question. Yeah, be careful though. Right. So our Vault tutorial got postponed, unfortunately, but it's going to happen February 25th at the moment between 11 and 1. You can still register. Registration is open. Please go ahead and register if that's something of interest to you. And then switching to the forum, there were, as always, good questions. Number one, somebody was asking about HSDS. Is it self-hosted? I guess that the person meant by that, can I host it myself? Yes, absolutely, you can. And that's what I think John Reedy replied, and I replied. Take a look at the Quick Start Guide, for example, on GitHub, that describes exactly if you want to run a local instance of HSDS just for testing. That's easy to do. Another thing is, if you are using Python and you have an existing Python script that works with traditional HDF5 files, there is a API compatible module available called h5pyd that you can install via pip. But I also linked here the GitHub repo. You can also build it from source if you like. And then the only change you would have to make for your Python script to work, which means to talk to HSDS rather than to the HDF file in a file system, you would have to alias h5pyd. So you would basically say import h5pyd as h5py, and then everything else in your script should be qualified or is written with h5py in mind, and that should work just fine. And then I think John added there is a great webinar that we had. So here's a link to a webinar that shows how to set it up, how to work with it, and so forth. And then finally, before you maybe want to contemplate setting up your own server and getting into the whole Kubernetes or whatever infrastructure you want to use for hosting that, the HDF Group hosts this nice Jupyter Hub installation called HDF Lab, for which you can sign up. And there are plenty of examples in HDF Lab that you should go and check out, and you can use them from Jupyter notebooks running in HDF Lab. But I will actually, if we get to it in a few moments, show you how you can actually interact with this RESTful service from your own laptop or desktop. I'll show you that in a moment. And then once you are satisfied with that and you think that that's the way you want to go, then you can sort of think about more elaborate deployments in a public cloud or with OpenStack and whatnot. Okay. Next up, yeah, somebody asked about converting seismic data, SegY format to HDF5 data. I would say this is really a question more for domain experts, because we are just in double quotes geeks, and we are lacking the domain knowledge of what geoscientists or geophysicists, I think in particular, associate with that data. It's certainly, I think a well understood process how to represent the SegY content in HDF5 data. And I linked here, these are sort of, there is this ASDF format, and there is a paper here where people describe how to present the different geophysical time series and whatnot in HDF5. And then likewise, there is the seismic data portal, I think that's what it's called, where there is tooling for ASDF, but I think there might be also some conversion tools from SegY to ASDF. And again, ASDF is just a specific flavor, a specific profile, as we say sometimes, of HDF5. So yeah, I would recommend to the user to go there and look for more, because yeah, we are not geophysicists, so we are not geoscientists, and to us everything is just more or less bytes. Okay, then there was sort of a post that was sort of revived, that was posted maybe 4 years ago, and it was this question about supporting variable length data with parallel I/O, and if there had been any update. At the time, I believe Elena responded saying, yeah, it's definitely on our list, but nothing specific scheduled. And all I can do here today is more or less repeat that. I think besides, of course, finding funding for something like that, there are some technical questions here, in the sense that the current internal representation of variable length data is rather inefficient, and we can talk another time about why that is and how that is and whatnot. But for now, just take my word for it. And it probably would not make much sense to try to parallelize HDF5 on top of this rather inefficient representation, because I think if we're going to do a better job from a performance perspective, I think we should first revise and fix the weaknesses of this variable length representation, and then on top of that, we can think about, I think that should be one of the design criteria also when we do those fixes and revisions, that it should simplify the parallelization of that. But so unfortunately, all I can say is it's on our minds all the time, but we have no specific plans. And then as far as the order goes, I think coming up with a more efficient representation of variable length data and then parallelization, that's probably the order in which things will happen. And it's not that we don't know. I mean, if you look at device manufacturers like Garmin and so forth, they obviously have created very efficient representations for variable length data for their embedded devices and so forth. So there are many of these things are well known. It's just retrofitting something like HDF5 with that after the fact is a major engineering task, and that's why it's going to take some time. And then this was just a question about Fortran, where from the error message, as far as I could see, the library seemed to complain about that H5T native double is not a valid data type. I think that's wrong. There is probably something else, because that is obviously a valid data type. I think maybe it's something along the lines that maybe the user was using dynamic linking, and the library could not find that shared library. I've seen that similar error messages in .NET, for example, in the past, where when you had a .NET application and launched it, and then the initialization failed because this is backed by a predefined sort of library internal global variables. And if they don't get initialized properly, then you would see the types of messages where when you try to create a data set and you pass one of these predefined types as an argument, library, since they were not initialized, they are -1 as an integer, so, or h5i underscore invalid underscore HID, then the library will complain and say this is not a valid data type, and -1 as a data type handle is not a valid data type too. But the root cause is that the library wasn't initialized properly to begin with, not that this is not a valid data type. So I responded like that. Okay, we have a few minutes, but before I jump into this, I'm going to pause and ask, are there any other questions? No? Okay, so I thought, well, since we talked a little bit about HSDS, let's just talk about it a little more. And first of all, HSDS stands for Highly Scalable Data Service. And you can think about it here, I put it in double quotes, HDF5 as a service. Well, what does that mean? Well, if you want to express it in even more technical terms, you can think about it as almost a web service interface for HDF5. You can speak basically over the HTTP protocol. You can converse with an HDF5 file in double quotes over the HTTP protocol. And if you know a little bit about the HTTP protocol, it's basically a protocol where you have a few, I think up to 7 primitive operations such as get, put, and post, and info, and delete, and whatnot. But you have these few primitives, and then you refer to the things that we otherwise call data sets and groups and so forth. In this more general context, you refer to them as resources. So what's located at a particular URL is actually a resource. Like there's probably a link to today's weather in Los Angeles. And so today's weather in Los Angeles is a resource, and I can send a GET request to that, and that will tell me some kind of synopsis of the weather in Los Angeles. Of course, today's weather in Los Angeles means something different tomorrow, but that's understood. I can put a GET request there today, and I can submit another GET request tomorrow, and I'll probably get a slightly different answer, but that's expected. And there is sort of this architectural style that also known as REST, as representational state transfer, which basically means that once you have represented something as the set of these resources, then through a protocol like HTTP, you can find out something about the state of these resources, like the weather in Los Angeles or something like that. And you, this whole thing is stateless in the sense that if you talk to the web server and then come back and ask the same question again, the web server does not know. It does not maintain a state that you, the client, just asked that question before. It probably will do some caching and so forth, but it does not maintain a state where it tracks, okay, this comes from this client, this comes from that client. Yes, in the case of the HTTP protocol, something was later developed that's more of a browser feature. It has nothing to do with HTTP, so-called cookies, but that's a whole other story. It has nothing to do with REST, and in a way runs counter the idea of REST, although you push the maintenance of the state to the client, to the browser, to the cookie cache that your machine contains. But that's a whole other discussion. Okay, so now I said we represent HDF5 files, or in HSD terminology, an HDF5 file is what's called HSDS domain, and you can query such a domain. So since this goes over the HTTP protocol, there must be a URL, and here's an example of a URL that again comes from the HDF lab. This is one of the publicly available HDF5 files or HSDS domains, and we can send that a GET request. So I can say GET HTTP and then put the address in here, and the domain that we are talking about, John really created a set of shared domains, and he just called them the way the names of HDF5 files might appear in a file system. So there is one called tall.h5. And when you do that, you get a response from the web service. I can actually show you. I did that just to in preparation for this here in Emacs. So if I place my cursor over this GET request, I can just hit Control-CC, and that sort of goes out there over the internet and talks to HDF Lab and says, well, tell me something about this tall.h5 file or domain. And then it comes back, and now I'm switching back to the other representation. So it will tell you something, an identifier, the root group. This is a domain. The owner, in this case, it's the administrator of HSDS. This is a representation of time when this was created. Then there are certain restrictions on how small or how large chunks can be in the sense of chunk data sets and so forth. How big, since this goes over the wire, over a network, there might be restrictions on the request size, how much data you might be able to send to the server or receive from it, and then how many chunks, the maximum number of chunks that you can request in one go. And then the requestors, this HTTP protocol also supports compression of messages with gzip, but here we also support quite an array of other compression methods. This is the version of the HSDS server software. And then there are some what's called related resources. So this is basically when you get a reply from a web server, the web server tries to be helpful and also tries to tell you something about related information. And in this case, the related information would be, okay, self, it basically repeats This is the URL that you just called. And it will tell you something about, think of this as the table of contents of data sets in such a domain. This doesn't really exist directly as such in an HDF5 file, because in order to discover all the data sets in an HDF5 file, you have to sort of iterate by traversing links and ultimately find out what data sets are there. Well, in the case of a service, you can, this is always an opportunity to give you something more rather than what you get with HDF5, meaning this ability to traverse an interlinked structure and discover things. Here we can actually give you sort of a table of contents of all data sets, and likewise a table of contents of all groups, so database, group base, and then if you want to talk about committed or linked data types, there is a table of contents for that as well. And then there is the root group here. You have access control. So for the data, if you want to try out HDF Lab, of course, your data is not public by default. It's private to you. But if you would like to share some of your domains with others, then you can do that through these access control lists, and there's plenty of documentation. And then, yeah, sometimes there is a parent-child relationship between these domains, and you can express that as well. And so just to be more specific, so the service just told us that we can find the root group of this domain or this HDF file at this URL. So let's just go out there and ask that question and find out, well, what's going on in that root group. So I can just hit Control-CC here, and that goes out to the domain and returns some information about the domain. And here, and I just in the interest of the font size, I'm going to show you what that pre-canned thing looks like. Well, as we know, a group is a collection of links. So here's a links, and in JSON notation, a bracket means this is going to be an array. It's an array of link presentations. It's going to be a link here, and the name of that link that refers to a group in this case is G1. And here's another group or link to another group called G2. And then, of course, not that fast, but you could compare the two identifiers. These are like addresses, offsets in a file in a real HDF5 file, so to speak. But since they are different, these two groups will actually be different groups. So if you want to visualize that, we have the root group, and in the root group we have two links or two subdirectories, so to speak. One is called G1, the other is called G2, and then that's the first step. Now we could do that again. We could go to either group and say, hey, what kind of links do you have? What about data sets and so forth? And I think we are close to running out of time, but I just, for example, included here, this is one of the data sets. So you can then go to a data set and you can say, well, you would like to know the standard things. What is the rank, the dimensionality of that data set? What is the type? And is it chunked layout, or is it contiguously laid out, and so forth? And here you see, for example, this is for one of these data sets. It's just a one-dimensional data set. It has fixed size 10. It's IEEE 32-bit floating point numbers. It happens to be chunked, and then there are some attributes here actually. Oh no, it doesn't have any attributes. So here it actually tells me if a given HDF5 object actually has any attributes or doesn't. And if it did have attributes, then there would be another URL for these attributes. And here's actually, like, there's a table of contents for groups and data and so forth. There is, if you wish, for each object a collection or a table of contents for attributes. So if that had attributes, we could find out. And unfortunately, we are out of time. I'm happy to come back to this in the future. If you have any questions, just leave a question in the Google Doc or in the forum, and we'll get back to this. But yeah, I encourage you, if you really want to understand deep down what this HSDS thing is about, use your favorite REST client and register for an HDF lab account, and then you can play with that. And then create your own domains and do similar things. So to me, this is a very exciting thing. And don't forget, it's HDF5. It uses the same abstract data model and so forth. It just uses a completely different technology to achieve that. And that's going to be it for today. And thanks for coming, and see you next time.
Okay, thanks, Gerd.
Thank you.